Hey there, and welcome to, we're deep in the bowels of Fort Jax here, doing a video lecture just to keep us on track of Chapter 8. In case you're wondering why I canceled class on Tuesday, here's a picture. Here's our house on October 30th. Halloween is a huge deal in the Essex neighborhood. And not to be outdone by my neighbors, but I'd set up a huge haunted house kind of display area in my garage every year with things that jump out and scare all the children. So that's how I have fun on Halloween. And finally, here's the number of visitors we had on Halloween, 640. Now that does include some adults. I'd say it's over 500 actual children that we were giving out candy to. So my wife and I use our project management skills every year. We come up with a budget, we do capacity planning, forecasting. It's all hands on deck, and I just can't leave my wife alone to take care of 640 people. So that's why I had to kind of juggle things around this week. So I really appreciate your patience. As a reward, I will include a lot of tips on how to complete homework number 7 successfully in this video. So you'll have to watch the whole thing to get those tips, but I'll try to make it worth your while. We're covering Chapter 8, which is all about routing and IP addresses. So these are the two big important things that happen at Layer 3 on the 5-layer model. Layer 3 includes IP addressing and routing. Now, I take some of the topics out of order compared to the way Panko does it, because to me it makes sense to talk about all the routing stuff together and then all the IP address stuff together instead of going back and forth and back and forth. So same content, just slightly different order. We will also talk about typical interview questions that you'll get. A lot of the interview questions you'll get, especially if you're interviewing for a junior network position, network engineer position, network analyst, sysadmin for a company. There's stuff in this chapter that will be the answers to questions you're going to get, and I'll give you some examples towards the end. So we need to talk about IP addressing again in a little more detail than we did before, about what subnet masks are and the difference between the two, the difference between a border and an internal router. You'll see that on your homework assignment. And then what a router does, specifically step by step. And then do a slightly deeper dive into IP version 6, which is still pretty new, but this is the world you're inheriting. And then some review of TCP and UDP. Now with every lesson, we kind of start off with the layers. Where are we on the layers? We're talking about mostly layer 3 with IP addressing and routing. A little bit of layer 4 in this chapter for some reason with TCP and UDP. But this is it. Chapter 8, this is the essence of networking. Understanding how IP addresses work, understanding how routing works. That's what networking is all about. Some things to remember from earlier in the semester. Remember that every single device on the network, every host, has to have an IP address in order to communicate. Now, just to be technical, it's every single NIC has to have an IP address. For example, your laptop actually has 2 network cards in it. Most servers have multiple network cards in them, either for redundancy or greater throughput, but every single network card has to have an IP address, just to be technical. But in general, every single device, at a minimum, has to have one IP address. Remember that there's a difference in private addressing and public addressing, and NAT is what helps us do that, make the shift from having one public IP address that's translated into many private addresses. So your private IP address scheme is going to change inside your network compared to what your public IP address is. And how many bits are there in an IP address? You better have that memorized at this point. Routers are very different than switches, other than the obvious. A router works at layer 3, a switch works at layer 2. A router works with IP addresses, a switch works with MAC addresses. Also, this is a new slide, but I see why he added it, that technically the little RJ45 ports on a switch are called interfaces on a router. Why? Just because. So if you need, on a switch, we talk about resetting a port. On a router, we talk about bouncing an interface. You bring down an interface and bring it back up. By the way you bring up an interface on a router on a Cisco router running Cisco iOS firmware. To shut it down, you do shutdown, interface, and then the name of the interface, like E1 for an Ethernet for the LAN side. So shutdown, INF, E0. And to bring it up, since bringing it up is the opposite of down, the command is actually no shutdown interface E0. It's a peculiar Cisco thing, but FYI. So if you hear my language change in this chapter from ports to interfaces on the back of the router, that's all I'm talking about. The serial WAN interfaces and the Ethernet LAN interfaces. At a minimum, you'd have one of each, right? You'd have one serial going out to your WAN and one Ethernet connection going into your LAN. It's possible to have multiple Ethernet connections if you're using the router to connect multiple networks together, like we're doing in homework number 7. Routers come in all shapes and sizes. These are some older models, but I just want you to see kind of the form factor from, one rack unit, the pizza box size. Well, this would be one rack unit versus, tabletop model, 3 RU up to 8, 12 or more rack units in height when you're rack mounting these suckers. It's pretty common now for a single chassis to actually, this gets confusing, but to have both a router and switch ports on it. Also called a layer 3 switch. So a layer 3 switch just has a router and a switch all glommed together in one big chassis. Every router has two sides. We'll do this over and over until you just kind of get it in your head. And grad students, I don't think we've got any in 468, but this will come up on your exit exam. Just remember, you never plug servers into routers. There's no place to plug it in. There's no place to plug a server into a router. You plug servers into switches. Because every router just has an in and an out, an inside and an outside, a private and a public, an internal and an external, a LAN and a WAN. Different manufacturers call it different things. It's all the same thing, an in and an out. A router is that thing you use to connect two different networks together. It is the only thing that you can use to connect two different networks together. So in this simple clip art I grabbed off Google Images, we don't talk about a NAT router. The router is typically performing NAT, although it might be your firewall that's performing NAT. And I can't remember which one I said. I think on the homework assignment I said your firewall is performing NAT. But on the, you're connecting the outside with the inside, with the public with the private. A border router is simply the router that's at the edge of your network. It's the device that connects you typically to the cloud. It's on the edge. So if this is your ISP, there should be like I prefer a cloud icon over here for your ISP, but your border router is the thing that connects you to the cloud. It's on the edge of the outer perimeter of your network. Now contrast this with an internal router. An internal router could be a slightly less powerful box, for one thing. Maybe it's a less expensive box that you use to connect different subnets, different LANs inside your network. Now you might be wondering, why do we need to do this? Do you have to use an internal router? No, you don't have to use an internal router. A lot of times this happens in a legacy situation if you've got two different networks that you need to connect together, particularly in a merger or acquisition situation. You take over another company, so you're taking over their network. You want it inside your network, but they used a different IP address scheme or a different protocol or different. You don't care how different their network is. A router is that magical device that's going to get the two networks to talk together. So if it's inside your network, it's just going to be an internal router. There are good reasons to use internal routers, especially for a large company. So for example, a router is going to limit broadcast traffic. The traffic that goes out to 255.255.255.255, such as DHCP requests. There are lots of devices that generate broadcast traffic, a lot of chatter on the network. So a router is going to filter that out. A router also can enhance security by isolating traffic. Now remember when we talked about managed switches, a layer 2 device, a managed switch can create VLANs, virtual LANs, to segregate traffic, but it's segregating them virtually. So remember, virtually is a word in English that means not. So if you're virtually separating traffic, you are not really separating traffic. If you're virtually done with your project, you are not done with your project. If you're virtually studying for my exam, you are not studying for my exam. So virtual means not. So a VLAN at layer 2 is just not as effective as a router that creates a physical boundary. It physically separates the traffic. So a router is much more secure and more expensive than a switch. A router is that magical device that can connect networks that are running completely different protocols. Back in the day, if you were running TCP/IP and I was running AppleTalk, or I was running Novell IPX/SPX, or I was running Microsoft's proprietary crappy protocol stack, and I needed to connect our networks together, or IBM SNA, any number of network protocols that really aren't in use anymore except for very bizarre legacy situations, a router is your solution. A router is a box that can connect any two networks together. Also, if you're using a 172.16 range of IP addresses and I'm using 192.168 because I'm an idiot, or because I'm smart, I'm using a 10-net address scheme. We'll talk about why later. I'm using a 10-net address scheme and you're using a 172.16 IP address scheme. A router can make sure traffic flows between our two networks and takes care of all the translation of and routing of IP addresses. Another area to contrast switches and routers, a switch does have a table of MAC addresses. It's actually called the spanning tree, not a switching table, but you can think of it as a switching table. A router has a routing table that's out routes. Routers route by using a routing table that uses IP addresses, but you just have to memorize this. Really important ideas I call tattoo worthy. Another difference between switches and routers, you can ignore some of these 3 of 5 bits that I should have deleted out of the publisher's slides because I doctored them. Anyway, I'm muttering. Another difference between switches and routers, switches, if you're using Ethernet switching, you can never have a loop unless you use a special protocol called RSTP to have redundant links between switches. Routers, on the other hand, are designed to be, fully meshed, to have multiple paths. You can have all kinds of loops because routers are smart enough to tell that there are multiple paths to the same destination. There are multiple paths to the possible paths to the same destination. That's what this slide is showing you. And thus, in a routing table, there may be multiple entries where multiple interfaces on the router that it could send out an IP packet and it'll get to the destination. So the router has to make a choice about what's the best path, what's the best interface to send it out. A routing table typically, no matter what brand you use, is going to have the following elements in the table. A range of IP addresses for the destination, the subnet mask, the interface, or port, just the physical interface to send it out. We'll talk about what a metric does, but this idea of a next hop router is important. As we move from router to router to router through the internet, or through any network, but through the internet, as you saw when you did traceroute in the first assignment at the beginning of the semester, as you move from router to router, that's called a hop. So we measure distance in terms of hops. How many hops away is it? Again, just an example of what a routing table might look like. Just a table with columns and rows, row numbers, the destination network, the mask, we'll talk about that, a metric, a numbered interface. Remember, when you're counting with any Cisco product, you start with 0, so there's probably a 0 interface on here also. And then what the next hop router is.